this podcast, I'm going to talk about Chapter 3, which is marginal analysis. And what does it mean to be marginal? First, let me tell you about slopes of lines. This is a line that slopes upward. It has a positive slope. And as the line begins to flatten, it approaches zero. And a flat line has a slope of 0. This would be a negative slope. It slopes downward. It also approaches 0 as it flattens out. Now, there's a good relationship between acceleration and marginal analysis. For example, as a motorcycle, if you're riding a motorcycle, you're accelerating very rapidly in the beginning, and then your acceleration begins to slow down as you go faster. Acceleration is equal to the change in speed divided by the change in distance. Now, marginal analysis is the same as acceleration, so as you consume more, your marginal benefit decreases. Activity is analogous to distance. Total benefits analogous to speed. Acceleration is the change in speed and the change in distance, and that's the same as the change in benefit divided by the change in activity. The change in what happens on the y-axis divided by the change in what happens on the x-axis. The change in the y-axis divided by what happens on the x-axis. Just called different. Same thing. This is a graph of mapping out the total benefit and total cost. And you should consume or do something at a point where the net benefit is at its greatest point. Just like the motorcycle, the slope of the line changes along the line. And if we want to determine the slope, we have to zoom in on one particular point of the slope. So if we zoom in, right on that curve, looks like this. We're zoomed in real tight now. The first point's, the x value is 150, or the activity. The benefit's 1100. The second point is 250 and 1740. The slope is the rise over the run by definition. So we take 1740 minus 1100, which is the distance over there to the left-hand side of the slide, divided by 250 minus 150, which is the bottom. So we know that the slope of the line is equal to $6.40. So back to our chart, what we see though, as we move along, the slope of the line becomes flatter. The slope decreases. Slope is more, slope is less. Acceleration is more, acceleration is less. If we just plotted the slope of the line, or the marginal benefit, we see that that line slopes downward. So the first slope that we plotted was $6.40 at an activity of 200. Now, the net benefit is where the slope of the line is the greatest, or the distance between these two lines is the greatest. Also, what's interesting is the slope of the lines are equal at this point as well. The slope of the line of total cost and the slope of the line of total benefit. So if we go back to our marginal line, draw that in there, 350 and 520. So what this says is that the greatest benefit is where marginal cost is equal to marginal benefit.